then we discuss it kind of thing. Like you start it, then I can go, then Keith, and then you, like that. So it's more, it's
Okay.
so no one. Yeah, that's cool. Okay. Is it 4 or 5?
5.
So the effect of outlier coefficient is not significant. That is false because it's really important, and it does have a correlation.
Uh,
I mean, it does have an impact. Sorry.
okay. So,
Keith, do you want to read the next one? Oh, sorry. What?
sorry. My husband was talking to me. So you said false?
Yeah.
Okay. Perfect. Okay. Sorry, keep going.
Input the
Okay, it's
correlation coefficient. So I put 901, 0.901.
How did you get to 0.901? That wasn't even close.
Is that what you got, Camille?
Yeah, 0.901. I just opened the file on Excel and then I use I use like the a specific chart for it, and I just typed in the numbers, and that was the
Oh,
correlation coefficient.
was it in like
Just
analyze the data?
see, so it is called quantitative inference procedures, and it's under the tab that is called linear regression.
Oh, right. Okay.
So I pasted it there, and then there is this chart that says model summary, and there is your R, or your correlation.
Okay. Sorry, I'm trying to do it right now. You can keep going now.
Oh, no, it's fine. We can't wait for you.
I see what you did there. That was smart. Okay. Okay,
Thank
that
you.
makes sense. So 7. What is the direction and strength between weight and duration?
Um, it is
Between weight and duration.
positive and strong.
Positive and
Be
strong.
positive and strong.
Nope. Match the scatter plot with correlation coefficient. So isn't, sorry, I have something in my throat. Isn't number 1 R equals 1?
Yeah. So yeah, number 1, it's R equals 1.
And B would be R equals 0.95?
0.95, yeah. And then number 3 will be 0. Then number 4, I believe it's -1.
Yeah.
Then 5 will be -0.95, and then 6 will be -0.6.
Okay. All right.
And then I have next question, right?
Uh-huh.
So it says input the correct correlation coefficient, and I did the same thing that I did before, and I got 0.728.
That's what I got too.
Okay. I'm just doing it right now. But you can keep going while I do the little graph.
Okay. And at question 10, it talks about the direction and strength, score and between score and confidence, and I believe it's positive and strong.
Okay,
Yep.
just to make sure you guys got 0.728, right?
Yeah.
Okay. That's what I have on my little thing here. Okay. Cool.
All right. So let's go to next quiz.
Yeah.
Keith, I think it's your turn. Do you want to start reading the first question?
Yeah. Given the linear regression equals 2.0 plus 1.5x, what is the y-intercept? That'd be 2.
So I think it's 2.
It's 2.
Sweet. You want to go ahead, Haley, or are you working on something else?
I'm just sorry. I'm so sorry. I'm trying to get into it.
No. It's okay. It's okay. We can for you. But we can. So guys, how are we gonna do the describe the data thing?
Let's
'Cause
see.
I have like 3 exams this week, and I don't know. Like, are we gonna all do it, or are we gonna assign someone? Or, yeah, I was just wondering.
The describe the data is basically what we thought was last weekend. We all submit our numbers, and one person writes them up like we normally would.
Okay. I haven't looked
So
at it, but I can do that.
I think and it says 3 paragraphs, and it says no more than 2 pages. So anything between 1 to 2 pages, I think you can just write whatever.
Write whatever I feel like.
Yeah.
Okay.
But,
So
but yeah. So
sorry. So we're just putting. Basically, you want me to put all of our numbers into into the same document, right?
no. So this document is different. Oh yeah. The same document, but then they describe the data. It's gonna have like the instructions of what you need to include. But it's basically just talking about the data and what represents, and yeah, basically that.
Okay. I mean, yeah, I think I could probably handle that.
Okay, perfect.
Okay, so we're on 4.
Yeah.
Okay, the linear regression equation. Slope. Oh, isn't this like basic algebra?
Yep.
Oh, goody.
Which one is it, Haley?
Sorry, we're solving for x, aren't we?
No, it's just 1.5. That's the slope.
Oh, right, the slope. Yes, because then it was, sorry, mx plus whatever. I just have it flipped. Okay.
Yeah. So in here, the y-intercept it comes first, and then you have the
So the
slope.
y-intercept is. Okay, sorry. Keep going.
So, given the linear regression equation, blah blah blah, what is the predicted value of y when x is 16? And I got 1.
You got 1?
It's 1.
It's 1.
Doing it
Sweet.
on my phone right now. But I am sure you guys are right. Yep, 1.
All right. Perfect.
All right. For the
Um,
next 7 questions, use the data file. Be sure to use the confidence data next variable and the score data as a response variable. Make a scatter plot of the math self of the 3 data shapes introduced in the reading. Which shape best describes these data? Hot dog.
Oh, no.
hot dog. Yeah. That was the first. I'm a little sick. That was the first thing I saw.
So,
Go ahead.
oh, sorry. I was about to read the next question.
Oh yeah, go ahead.
Okay. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? So, simple linear regression is appropriate for this data. If simple linear regression is, I would say A.
Yeah.
Yes, ma'am.
Okay. Ma'am. How old am I, Camilo?
I don't really know, but I was just being I was just being a gentleman, you know.
I know. I was. Okay.
Wait, how old are you, Haley?
26.
Are you serious?
I'm 25. 26 this December.
Well, you're
Yeah.
25. You have 4 kids.
Yeah.
Wait, when do you have your first kid?
When I was 21, I think.
Wow.
Yeah.
think-
I got married when I was 18. I was like turning 19 in a few months. So.
That's cool.
Yeah.
Okay.
You're a baby.
No, I'm not. I'm like, we're basically the same age.
I know. Okay. So how many observations?
Wait. How old is Keith?
27.
27. Yes.
27? Okay. That's cool. Okay. Question 7, right?
Uh-huh.
Based on the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model this data?
No, Camilla, we're on 9.
8.
Oh, we're 9? Oh, 8. So how many observations are in the data? 139.
What is the
Keith.
y-intercept? And I got
Quick question. So
18.69.
that too for
8
question
point
9.
what?
189.
Sorry, you guys are cutting out. Say it again.
So for question 9, it's 18.69.
Okay.
Yeah, but wait, for question 8, when we're talking about the observations of the data, I wasn't sure what I was supposed to look for, so I just counted basically how many, because I didn't see any, so I did it on Excel, and I didn't see any charts or anything that it said what is it called? That it talked about observations. So just guess that it was gonna be the amount of that I had.
Yeah, that's all it is. I wasn't for
That's all
sure
it is?
first either, but that's all it is.
Okay, perfect.
Okay, so 10.
So
What is the
yeah.
slope? Get out my calculator.
Haley, if you're doing it on Excel, you should have a little chart, what's it called, square, rectangle, that it says slope B1, and then there's your slope.
Help me out here.
Are you doing it on Excel or not?
No, I always do it on SPSS.
Oh. Oh, you're that type of. Okay. SPSS it is.
I think that is the slope 2.887.
No.
Ugh.
No. It's 12.695.
Yeah, that's what I got.
Oh. Okay. I wasn't even looking in the right place. Wow. I suck at this. I don't know how I've survived this semester, to be honest with you. All right. So 11.
Yeah, sorry. So what is the predicted value of y when x 69.47? Yeah.
69.47.
Same. I'm looking. Yeah. I think I'm doing this math right. You can keep going. Sorry, I'm just working through some of these problems to make sure I understand them.
All right. So 12. You got it, kid.
The confidence data results from the students evaluating their confidence on a scale of 1 to 6. What is the maximum predicted value of y for these values of x? Because there is a possibility we can use the largest x value to find the largest predicted y value. So I did that in SPSS, and it was 94.895, and that wasn't correct.
Huh.
What did you get, Camilo?
So for that one, I got 98.6, and I got it right.
You got 98 point what?
Oh, sorry, sir. 94.86.
94 x.
6. So question 12, right?
Yeah.
So basically what I did, I just I grabbed 6, right? Because it's the highest x, and I just plugged that in the equation, and I plugged that in the equation, and and the result was 94.86.
94.86.
Yeah. Yes, sir.
Yeah, I did it in SPSS with 6, and it wasn't correct, so I was a little mad.
Because I did it by hand. So I basically grabbed I grabbed 69. No, wait. I grabbed the y-intercept, right? So I did 18.69 plus 12.695 times 6, and that's what I got, 94.86. But it is correct
for the test, because SPSS, it was not good.
Yeah.
It's very close. I mean, it's still 94, but it was wrong.
Which one do you get? Do you get 94.6? That's what you got, right?
Yeah, I got 94.895. That was from SPSS.
94.85?
Yeah, 0.895. 94.895.
Close. Yeah, that's weird. I
Okay.
don't know, man.
I see what you did. That's smart. I would have just used the SPSS number.
Yeah, I just applied the formula, the equation that we have.
Yeah.
Mm-hmm. Thank you. I
Okay.
feel so flattered, Haley.
Well, I'm crappy at math, so every time Camilla's like, "Oh, I just did this," I'm like, "Oh, I never would have thought of that." Okay, so how many explanatory independent variables are present in simple linear regression?
1.
Let's see, 2.
Just one.
Just 1. Oh, independent. Okay, yes. Oh, sorry, I read it and I don't even know what it was asking. Honestly, it's been a long day, guys, okay? Don't judge me here.
No, I'm not judging. I just got a text from my friend.
Oh, okay. I think you're sitting here laughing at me. I'm like, okay.
No. I'm sorry. I was gonna actually say that. I just got my text from my friend, and I just made me laugh.
Okay, so dependent variables is 2, right?
No, 1 as well.
Still 1.
Why is it 1?
Because the independent variable, it's x, right?
Yeah.
And then the dependent variable is always y, so it's just 1 and 1.
Oh, that makes sense. Okay.
Yeah, if it 1, it will be called like multiple.
Oh.
But a simple is always 1.
Oh, right, because it's just linear, right?
Yeah, that's why.
Okay, who wants to read this one?
Okay, so the last one says, A company in South Dakota manufactures hard hats used in the mining industry. Record measurements on all the hats they produce for quality control and planning purposes. The measurements they collect includes hat size, circumference of the hat, and the major minor axis. Meaning the company wants to predict size of a hat given the circumference. What is the response variable or the dependent variable? So it's a
Yeah.
Yeah.
because it is the variable being predicted. So we should all get 100, but I think yeah.
I honestly am just like lost my will to care. And I have senioritis hardcore. I'm about to graduate and I'm so done.
Wait, you're about to graduate?
Yeah, I'm graduating with my 2 associate's degrees this semester, but then I'm
Oh,
starting
sweet.
nursing in like a month at ISU.
All right.
So,
That's nice. Oh, so I think we're done for the week. And Haley, if you need help with data, just let us know.
oh yeah, I'll
And-
post to our little group chat thing if I need help. But I'll
Okay.
take your
Sweet.
cadence and put it all in the same chart.
All right, perfect. Haley, do you go to class today in Pathophies?
I did. I showed up late, and then I took a few questions, and then my husband came and for
Oh, okay.
part of the class, so I was like in the back with him.
Oh, okay. Perfect. Sweet.
And he was like, "Why'd you
all right.
bring me to this class? This is awkward." I was like,
Did a lot of people show up or not?
"Yeah, no, quite a few people did."
Oh, okay, that's cool. Yeah, I'm in Utah right now, so I couldn't go.
Oh, yeah. I mean, you didn't miss
Yeah.
much. It wasn't a very hard
Okay.
lecture. So, anyway,
Okay.
thanks, guys. I'll post
Happy-
this on our group meeting.
Happy 4th of July for everyone.
Yeah.
All
See
right.
you.
You too. We'll see y'all.
See you next